Okay, everybody. So we're trying to get the internet worked on. We don't know. It happened on Friday, and now it's happening again. Um, so anyway, I was looking at the final and what I want to give you guys for the final, and I say final, midterm, whatever, loosely. It's not going to be worth 200 points or anything like that. Um, and based on how we're doing this home remote learning, I think what I want to do is more like a little quiz, and then like a little tiny um, midterm, like something small that's just got the real basics on it. So what I'm going to do is we're going to learn another topic, and we're going to take a quiz on this topic, okay? And it's called inverse functions and relations. Okay, so let's go ahead and take out our notes, and we're going to start with what is a relation? And it's just a set of ordered pairs. So I want you to think about that everything that we do in math that has an x and a y is called a relation. Okay, so if you've got an x and a y, it's automatically a relation. Now, remember that we have functions also, and functions are special types of relations. But for right now, we're just going to talk about a relation, and then we're going to look at a thing called an inverse relation. Okay. Now, an inverse relation seems like a pretty abstract idea, but I want you to think of something really, really basic as far as how do we know where this thing is going? Okay, so I want you to think about if, back in 7th grade, 6th grade, we got something, like a problem like this, oops, not a plus, an equals, and we said, okay, how would we solve this? How would we get this x all by itself? And we said, well, you would do the inverse or the opposite of subtraction, which is addition. And so we kind of think about like by doing this, it's like we undid it. If you almost think about it that way, you're undoing it and you're getting x all by itself. Okay, and a relation, when we're talking about an inverse relation, it's like we're undoing a function. So just kind of keep that in the back of your head for right now. Okay, so an inverse relation is also a set of ordered pairs, but they're backwards. So all you do when I say backwards is you just switch the x and the y. And this little definition has a lot of applications. So again, this is one of those things. It's not hard to find an inverse relation. You just have to remember what are you supposed to do. So every time you hear inverse, inverse function, inverse relation, I want your brain to go switch x and y. And you're going to see it in lots of different ways, but if you can remember switch x and y, you're set. Okay, so let's say that we have some relation, and I'm going to call it A. And let's say that A is equal to some ordered pairs. So it's just going to be 3 points. So it's not like really a function at this point, but let's just say it's those 3 points right there. Well, if I asked you to find the inverse of A, and a lot of times we'll just write inverse of A. Well, all we do is we switch x and y. 3, 1, 4, 2, 5, 3. It's literally that simple. Now, one thing that I want you to think about is how is the domain and range of a function and its inverse related? Okay, and this is going to be a big deal. Hold on a second. Okay, I paused.
Tech's on the way.
What's that?
Tech is on the way.
You're the best. You know, the only person, Chad Lawrence is like, no, mine's working just fine. But Paige was like, mine's out, hers is out, Doug's is out. I don't know about anybody else teaching in this building.
Okay, I will survey. Thank you.
All right, thank you. Uh-oh, are we still recording? Oh, okay, we're still recording. That was Mr. Harnett coming in. They're going to fix the internet. Okay, so let's look at how our, oh, I have a freeze on here. Okay, I think this is working. Okay, we want to know how are the domain and range of inverse relations related. Because this is going to be you're going to see one thing that's very powerful with working with an inverse. We're going to see eventually that we have to be able to find the domain and range of a function from an equation, not from a graph. And we'll see that finding the domain isn't so bad, but finding the range is very difficult from an equation. So this is going to be very helpful when we have to do that. Okay, so let's look at A here. So this relation right up here. Well, remember that we said that the domain is just the x values. Okay, so when we have something like this, where they're just points, we literally write the domain as 1, 2, 3. And that's it. The range is just the y values. So 3, 4, 5. Well, let's look at the inverse of A. Okay, so the inverse of A, the domain, and again, I'm just doing the x values, 3, 4, 5. And the range, 1, 2, 3. Okay, so notice what happens, that the domain of A is the range of the inverse. The range of A is the domain of the inverse. So they just switch. So we're going to say that the domain of a function is equal to the range of its inverse. And the range of a function is equal to the domain of its inverse. And like I said, this is going to be a pretty important topic later on when we're finding domain and range. Okay, so let's look at notation on when we're trying to find a function. So f of x, oops, let me go out here a little bit. That's the function. And f negative 1 of x is the inverse of the function. Okay, now what happens if I have an actual function algebraically and it's not just points? So let's look at how do you find the inverse of a function? Okay, and let's give an example. Let's say that I gave you this function, that f of x is equal to 2x minus 5. Okay, so I'm going to put it up here. Okay, the first thing you do is you rewrite the function, or I'm going to say rewrite f of x using y. Okay, so I'm going to, instead of f of x is 2x minus 5, I'm going to say y equals 2x minus 5. Okay, the second thing you do is you exchange x and y in the equation. Okay, so I'm just going to switch those. So I'm going to write x equals 2y minus 5. Okay, third thing, solve the equation for y. Okay, so I want you to think about this. I'm just going to move this 5 over here so that x plus 5 equals 2y. Okay, I'm going to divide each thing by 2. Okay, so do each piece as opposed to one big piece. Now, x over 2, that's the same thing as 1/2 x plus 5/2 is equal to y. And I could put y over on the left if I wanted to. Okay, then find my ruler here so I can make my line. Oh no, my ruler disappeared. Oh good, I found my little thing. Okay, so then what we're going to do, so we will put step 4, we are going to replace y with f negative 1 of x. Okay, so we have this, and I'm going to put that on the left. So I'm going to say f negative 1, and this is really the inverse of x. It's not to the negative 1 exponent, so it's just kind of a weird notation. And I'm going to write 5/2 as 2.5. And I'm just doing that because I'm going to graph these, because we're going to see, like, well, how are those related? Okay, so I'm going to make the next video that I'm going to show you how the graphs are related. And hopefully our internet will be working by then.